The reason for saying this is because we love NTU. NTU is like a home to us, and the welcome that we get from NTU, we can't really forget it. Even if they don't invite us, we'll just come. So talking about the circular economy, I mean, we have been talking a lot about the circular economy, so I'm not going to bore you guys with what is a circular economy. It's basically a circle, and we put economy into it to make it a circular economy. So that's pretty much it regarding the circular economy. But briefly speaking, in circular economy, what we do is we go for cleaner production. When I say cleaner production, like I mentioned, we try to reduce the carbon footprint, we try to utilize greener fuels, renewable fuels that emit less and less carbon dioxide so that the production is on the greener side. Now, when we use green fuel, the product that we achieve are generally greener. I'm not saying they're green in color, I'm saying that they are energy efficient products with less carbon footprint. One of the aims behind this model is to extend the life of the products that we make, because if we do not extend the life of the products that we are making, they will end up either in the landfill or will start burning them, which is not really helping the environment. So extending the life of the products that we are making is also one of the circular economy goals that we have to achieve. The other important thing which we have discussed yesterday as well, for example, Reverse Resources are working on it, is to collect the items that we have consumed at the end of their life and try to reuse them into usable products. So we can separate them, we can either reuse them, or we can take them back to the starting of the cycle so that we can recreate different products out of them. So if we are following this closed loop, we are working in a circular economy fashion. Now, what are the advantages that we can get out of this circular model? We can reduce the environmental footprint that we are generating as a result of the manufacturing processes, which is going to bite us very soon if we don't follow the circular economy principles, because EU regulations are pressing upon us. With this model, we also reduce our dependency on the new resources that we're generating, because we are using the resources that we already have. And one of the biggest advantage is that we will be reducing the waste, and by reducing the waste, we can also increase the income, which is badly needed for this economy. So what are the overall environmental goals, specifically in the textile sector? So just to give a brief overview of the textile sector, I mean, you guys are more aware of these than I am. So typically we produce around 100 billion tons of garments every year, in which out of 92 million tons goes to the waste. So that's a lot of waste that we are producing. Now, during the production of textiles, we also use quite a lot of plastics within our textiles, and these plastics, they end up in our waterways, they end up in landfill, contaminating our land and also contaminating our waters, which is not really a sustainable solution for it. So, talking about carbon emissions, in Pakistan, textile industry is one of the biggest contributors to the carbon emissions. So, to investigate the energy efficiency of the textile sector is also a very big challenge for us. We also generate quite a lot of waste every year. We're talking about 92 million tons of waste that the textile industry generates every year. So international organizations and governments are basically looking to improve the energy efficiency of the textile sector. So they are basically working in 3 domains. The first one is on the infrastructure development, and also they're working on changing the consumption habits of the consumer. Lastly, they're also working on infrastructural development in the textile sector. So I will be focusing on this very area so that we can actually progress and make our textile sector greener. So looking at the textile value chain, we have a lot of stakeholders starting from the farmers, then we've got weavers, then we've got the consumers, and then we've got the waste collector. So in this value chain, sorry, for some reason the slides aren't working properly. This happens every time. So most of the time we focus on end of life and we are not really focusing on the initial end of the textile value chain where the farmers come in hand. So we will be looking at the initial stage of the textile value chain. So if you look at the carbon footprint, so we are using a lot of water, we're using a lot of land, and also the worker safety is an issue when we are looking at the initial stage of the textile sector. Now, we produce quite a lot of textile waste every year. And the question is, where does this agricultural waste, where does this all go? We dump it in a landfill, or we start burning it, and what we do is we break tons and tons of records. So smoke is a really big challenge these days. As Shahid has also mentioned that during the harvesting season, what we do is we start burning the crops, and because of the season, all the smoke particles, they are integrated within the smoke, and that results in a smoke that is very unhealthy. Now looking at the production of the agriculture. So the first thing that we can do regarding the agricultural waste is the process called as pyrogasification. Now what is a pyrogasification process? So in pyrogasification, what we do is we heat up the biomass. In this particular case, we're talking about the agricultural waste. We heat it up at around 500 degrees Celsius to create a mixture of solid and gas. Then we take the gases out, we heat it up under limited supply of oxygen in order to generate a synthetic gas that consists of methane, carbon monoxide, and hydrogen. And the leftover items that we have is called a digestate, which is very rich in nitrogen that can be used as a synthetic fertilizer. Now, when we look at the main impacts of these pyrogasification processes in our textile industry, we have a lot of potential to integrate pyrogasification into the textile industry. For example, it can be used in dye sector, it can be used in the boiler sector, and we can also reduce the carbon footprint of our textile industry by using the gasification technology. So, I'm not sure what's happening in my presentation, but it looks like this is not the presentation that I made last time. It looks like it's all over the place here. So this happens all the time. So the bio-waste composition, so over here what I'm trying to tell you is that typically in a year we produce around 36 million tons of organic waste. And 70% of organic waste is produced in the urban areas of the country. And the composition is around 60% is food waste, with 25% of the agricultural waste, which is where we are focusing at the moment. Now, when we look at the potential of this energy, so we can generate around 2,500 megawatts of energy. I'm talking specifically about electricity by using this technology. And we can also generate methane gas from this very process. So now, if we talk about efficiency, the efficiency of pyrogasification is around 60 to 70%, but that depends entirely upon the feedstock that we have available within ourselves. So if we have a dry feedstock, the efficiency can be a bit higher compared to when we have a wet feedstock. So when we talk about the efficiency, I'm talking about the energy input that we use in order to heat up our agricultural waste up to a certain temperature, and then the energy output that we are getting, which is in the form of biochar, in the form of gas, or in the form of electricity. So what is the takeaway message from this talk? The world is changing and we have to change again. We have to adopt the circular economy model in order to compete with the growing demand of the textile industry. So there are opportunities available, as I mentioned, not only towards the end of the life cycle of textile, we have opportunities at the starting cycle of the textile value chain where the farmers come in handy. Now, how can we help you guys? So we've got energy and renewable energy projects available. So like, for example, Shahid mentioned regarding hydrogen technology, we've got higher gasification technology. So we can help you in order to achieve the carbon footprints that is required by international laws these days. We can also help you with improving the economic policies and developing a good governance for the textile industry. And also, we can help the farmers by returning the nutrients. For example, as I mentioned, the gasification, one of the byproducts is nitrogen-rich fertilizers that can be sold or given to the farmers in order to enhance the crop productivity. And we can also help you to generate funding, as we are running various projects with National Textile University internationally funded. So we can also help you guys in order to attract international funding. You guys are willing to work with us. So at the end, I would like to thank all of my sponsors and collaborators who have been funding my research over the past few years. And specifically, I would like to thank National Textile University, Dr. Yasir Nawab, Dr. Muzammil, Dr. Shiraz for their kind invitation over and over again. And I would like to take this opportunity to thank you guys for listening to my talk, and thank you very much.
Thank you very much. We are very privileged to listen to this wonderful presentation. It may seem mixed up to you, but I think the audience have been able to follow